at one moment in time. So we derive it, gives us our slope, and then we can put any x value we want in, tells us our slope, or our velocity, which is a form of slope. Well, were you ever wondering, like when we were like practicing all those rules, like what would happen if you were like multiplying things together? Is there a special rule for that? There is. Today we're going to learn the product rule. So we've got several rules in our back pocket. We've got power rule. We've got constant multiple rule. We've got all those we've been practicing. And we're going to add in another rule, the product rule. And I'm going to write it officially, like with like the math looking part of it, and then we'll practice. So if we are asked to take the derivative, so remember that that was a symbol we wrote down. That means derivative of, and then it was brackets, of some function that there's like two parts to it. So f of x times g of x. So this could be x squared times 5x squared. It could be x minus 2 times 3x minus 2. It could be sine of x times cosine of x. If we have two things that are being multiplied, that's when we're going to use this rule. Okay, it's going to look weird, but then I'll explain it better. F of x times g prime of x plus g of x times f prime of x. This is what we're going to do whenever we have things that are being multiplied together in order to derive them. Now, along with this, we're going to be getting into like lots of different rules, and all of the like symbols will start to kind of seem overwhelming. So I try to come up with little sayings if that helps you better to like know what this is. So I'm going to write down the saying. Whatever, if you like thinking formulas, if you like thinking sayings, I'm going to put the first times the derivative of the second plus the second times the derivative of the first. And in this little saying, the first represents whatever function is in the beginning, and the second is at the end of it. And so basically, we're like mishmashing it. We're keeping one original and one derivative, and then we're flipping it. The other original and the other derivative. And then we're adding them together. So that's what we're going to practice today. Just this one rule. That's all we are going to get better at today. Any ideas what tomorrow will bring? Yeah. Well, we'll wait till tomorrow for that. So we're just going to practice this and get really good at it. So here is our first one to practice. We're going to find the derivative of, let's make it h of x equals, in parentheses, 3x minus 2x squared. And then our second parentheses, 5 plus 4x. So this one, like as we're getting to know this rule, we want to be able to start picking out like what the two functions are. This one makes it pretty obvious. We've got two sets of parentheses. Those are our two functions. If we kind of follow the saying part, like this would be considered the first, this would be considered the second. And we're going to practice this rule. So h prime of x will be the first, so we keep it as the original, times the derivative of the second. So what would be our derivative of 5 plus 4x? 4. Plus the second times the derivative of the first. So what would our derivative of 3x minus 2x squared be? Yeah, and we've got to put that in parentheses because there's a binomial there. And we're going to leave it like that. That's our answer. If I said, what's the slope when x equals 2? What would we do? Plug in 2. So we'll work on when we need to simplify more. It's usually like when there's another step or they're asking us for more things, but it's part of that like AP calculus stuff. We don't want to do too much more work than they require of us for at the moment. So we're going to leave it like that. On this quiz, which is going to be next week sometime, this quiz, I always have people leave it like this, and like everybody's like coming up to my desk, is it okay to leave it like this? Like you get nervous, but yeah, we're going to leave it like that. Okay, let's try another one. We've already done one successful product rule. I think it's time to throw in a trig already. Let's do y equals t, yeah, I'll keep a t in there. I think we're ready for a t. T cubed times the cosine of t. So the important thing for product rule is you have to be able to pick out the two parts. So we have our first and our second part. And then our derivative, the first times the derivative of the second. So what's our derivative of cosine? Negative sine. And we want to put parentheses around that or put the negative in the front. Because if you don't put parentheses, you're really saying t cubed minus sine of t, and we don't want that. So first times the derivative of the second plus second times the derivative of the first. So what's the derivative of t cubed? 3t squared. Easy. There's our derivative. Ah. Look at that. This is one of those problems where it's like the numbers are like just ornamental almost. Look at all those letters in there. You show this to somebody, they would get scared. They think you're really, really smart that you can do this problem. All right, let's try another one. Still liking the trig, but I want to throw in a square root with this. Let's go. Square root of x times the sine of x. So we've got our two parts, pretty easy to see right now. We'll go to derive it. Now what I'm going to do, which you don't have to do, when I go to write down my first, I'm going to change it to a rational exponent. It's not necessary that you do that, but that's maybe more how we'll see it. So either form is fine. You could leave it as a square root. The first times the derivative of the second. So what's the derivative of sine? Cosine. Plus the second times the derivative of the first. So x to the 1/2. We bring our 1/2 to the front. Keep the x. Subtract 1 from the power. We still want to fix our negative exponents. Even though we're not really doing much combining, we want to fix that up a little bit. So the best way to write this, I'm going to actually just make that a big fraction like this. But you could make it two things. You could make it sine of x times 1 over 2 x to the 1/2. But I just smashed it together. Could I put all of this as one big fraction and put 2x to the 1/2 under this? Yeah, this doesn't, unless we wanted to get common denominators, which we could, but we don't need to worry about that right now. And if you like your radicals in there instead, perfectly fine, all the same. It's like too easy, right? Like, why didn't they challenge us with a product rule? Let's try this next one. Actually, I'm going to have you try this on your own too, but I love that. Let's do y equals 3x sine x plus x squared cosine x. Okay, now before you try this one, what makes this one a little bit different? Two product rules. So you've got the first one you'll do a product rule with, and the second term you'll do a product rule with. If the end answer, how many terms will you have? 4. Yeah. Okay, try it out for a couple minutes, and we'll check our answers. I'm going to start putting my answer up here so you can check to see how you did. It might be a little bit different forms, so there are some different ways this could end up. Something like that. Look good? All right, I can tell you want a better radical this time. Let's try this one. There we go. Let's do this one. Good fractions in there, right? Probably the most difficult thing was just figuring out, making sure you did 9 times 7/4, right? Was that it? Subtract 1 from the power, 3/4. You just had to fix the one negative exponent. But that's our derivative. Okay, let's try triple one. Let's do y equals. Let's try that one. And this could look very different depending on the order that you go in. And again, depending on your commutative property, could be looking different, but still equivalent. But there's our derivative. Okay, the next one I'm going to have us try, I'm going to actually have us plug a number in and get the specific slope. So for this one, I'm going to throw some radicals at you again, but then I'm going to have you find the slope at a certain x value. So let's do and after you derive it, find the derivative specifically at x equals 25. So this, depending on how comfortable you are, you might want to simplify it more than we have been process. But that's just based on how good you feel about your algebra. Your answer should not be a whole number. Who wants to share their answer? I like -1/2. We feeling okay about -1/2? That 25 was a nice little thing to put in the radical. All right, I think we're going to stop there for today. There's not much more we can do at this point. So I'm going to show you your quizzes from yesterday.